Okay, so we're going to go into simplifying exponents, and there are three major laws here that we're going to need to know. In fact, I might add two more just to help you. First law is the bases are the same, and for all of these, the bases need to be the same. When we're simplifying two bases, or two exponents that are being multiplied by each other, what we can do is just write it as a single base and add the two exponents. So an example of this is 6 to the power of 5 times 6 to the power of 3. We keep the same base, and we add the two exponents, so we get 6 to the power of 8. Our second example, if we're dividing exponents with the same base, again, we can write it as a single base and subtract them. So, using the same two numbers, we write it as a single base 6, but instead we subtract the two exponents, we end up with 6 to the power of 2 for division. And this one is called a power of a power, okay, when we're multiplying an exponent by another exponent. So we'll only have one base, so that means you're going to keep that only base, and you're going to multiply these two exponents by each other. So it would be written something like this, where we have a 6 to the power of 5 to the power of 3. Okay. And to simplify this, it's the same as writing 5 times 3 on the exponent. We get 6 to the power of 15. Okay. One or two other ones. I want you to write things as positive exponents. I think we might touch on this in another lesson. But if we have a negative exponent, to make it a positive exponent, we turn the thing into a fraction and flip it, right? Because we can make any whole number a fraction by putting it above 1. So to make the exponent positive, and actually the way I'm going to write this is on the outside. This way it helps you with fraction rules a little more. Okay. And we make the exponent positive on the outside, and we just invert the number. So let's say we had 6 to the power of negative 5. Okay. We turn this into a fraction, which is 6 over 1, and we invert it. So it becomes now 1 over 6 to the power of positive 5. And finally, x to the power of 0 is equal to 1. Okay? As long as x is not 0 in that case. So if we have 6 to the power of 0, any value to the power of 0 gives us a value of 1 when we're evaluating. So let's go through two difficult examples here. I'm probably going to need a little more room than that. Let's move that down a bit. In our first example, when going through the simplifying, we always want to use bedmass, okay? So we look into the innermost bracket, 13 to the power of 12. Well, we want to simplify. We're not evaluating anything. So the very first thing I want to do is deal with what's on the top of this fraction. This 13 is to the power of what? If there's nothing there, we assume it's a 1. Okay? So this is two exponents with the same base, and they're being multiplied by each other. So how can I simplify that step? That's right. We keep the same base, so we still have 13 on top. But we're going to take those two exponents, we'll underline them in blue, and we're going to add them together. So 1 plus 12. And this is a simplified version. Still above 13 over 7 to the power of 2. We simplify that. I guess I'm going to need quite a bit more room. 13, 1 plus 12, thank you, is 13 to the power of 13. Still above 13 to the power of 7 to the power of 2. I'm going to move this stuff down. Or actually, I'll move it to the... We would, but let's deal with what we have first. We can simplify... I'll move this to the left. We'll do it on the left here. We can simplify the brackets again. Okay? How can I simplify these two brackets? Well, how can I write them as a single power right now?
13 minus 7.
That's right. 13 subtract 7, because there is a division rule here. Okay? This will still be to the power of 2. But when we simplify it, we'll have 13 when we subtract this to the power of 6 to the power of 2. And then using the last rule, what do I do with those two exponents? That's right. So we get 13, and we're going to be multiplying 6 by 2. This will become what? 13 to the power of... That's right. Okay. So all of that can really just be simplified by writing 13 to the power of 12. Okay, so that's our first example. And our second example here. Okay. Same idea. We're going through bedmass. I want to deal with exponents. So I'm going to deal with the one farthest to the left. I have a power of a power. Okay? So I'm going to deal with that one first. We'll do this one step at a time. So what do I need to do with this here? I write this as a base of 5. Those two exponents become... That's right. They're multiplied by each other. Okay? And in that same step, okay, if you guys can think ahead, this will become a value, but this will be another exponent of an exponent. So I'll have to simplify this also before I can combine them because they're multiplied. So let's try to do this also in one step. This becomes base 5. What do I do with those two exponents? That's right. 5 to the power of 5 times 2. Okay? And we'll keep what's on the bottom. We'll do that after. That leaves us with 5 to the power of 8 times 5 to the power of 10. Divided by 5 to the power of 2. And these brackets don't really need to be written here. There's nothing to simplify. It's really 5 to the power of 13. Okay? So let's deal with the top by itself and the bottom by itself and then divide after. Okay? So if we're going to simplify the top, how do I write that as a single base?
5 times 5 to the power of
8. Not times. Plus. Okay? Plus because these are multiplied by each other. They're not a power of a power. Okay? So we got to make sure we distinguish our 3 rules when going through this. What about on the bottom? That's right. It's going to be 2 plus 13. Again, because they're multiplied by each other, these values, when we're simplifying. Okay? So we go to simplify that. We get 5 to the power of 18 divided by 5 to the power of 15. Yeah. And 18 minus 15, I'm just going to do this in one shot, gives us 3. So we get 5 to the power of 3. That's it. All we want you guys to do is simplify in these questions.